on this computer. Okay. So, right, exam. So I met with the TAs, all the TAs for this class and the next class on Saturday evening, and your TA, basically I got each of the TAs for each of the classes is grading their respective section. 2168, the TAs also apparently are grading the group exams. I thought I would be doing that, but hey, they're doing that. And so I gave them a couple directions, which I'll now tell you because that's relevant for you to know. I told them that when in doubt, grade things harsher rather than more lenient because you know they haven't really graded before, and so it is easier for me to give you points than for me to take them away later for if they were too lenient. So basically the strategy we came up with is that when in doubt, either let me know to grade it. Jovan told me that there were still a number of about 7 questions from different students I had to grade because he wasn't sure what to do. But they could grade it. I told them to grade more harshly because I can always get points back. And then I would be the final arbiter if students had issues with the grading. Okay, that's the way that will work. So, right, I'm sure a lot of you think that they were graded harsh. That's the way we were supposed to do that, just in case, because. And then the second part is that I did tell them to be more lenient on the ChatGPT ones, but again, I will still be happy to double check anything on your exams. I got it. So if you have questions on your exam, you think you deserve more points, you probably do, let me know. But that was just me making sure. But this enabled us to do a pretty quick first pass of the exams and get them graded to you, relatively quickly. Okay. Same thing with the group exams. Let me know if they still need to be graded or if they need to be, or if you have any questions about grading on those. If your group exam was less than, if the point score on your group exam was less than your point score on like if you got a 90 on the solo exam and 80 on the group exam, the 80 will remain there for a week or two, just so you can see what you got, or so also that corrections can take place. And then after basically the grades have solidified and you've had a chance to see what you actually got, I will then update the grades accordingly to make sure that your solo and group match if your group is lower than your solo. Okay. While we're making corrections about this, while I'm going around and speaking to you about your exam, I'll be happy to listen to your thoughts on and suggestions for this exam. The other thing I want to, let's see what else. Right, spring break is next week. I'm pretty much available all spring break if you want to meet. For the most part, I plan on working on my textbook / planning for my trip to Japan. So, so I'll have plenty of time if you need to meet with me to catch up on something. I'll also plan, once these exams are also fully finished and we're satisfied with that. So sometime next week, I plan on giving midterm reports. Now, until I am corrected on this, and because I think I'm correct about this, the midterm reports don't actually have any meaning other than an internal meaning for that semester, right? Doesn't matter what grade you get on whether you get an S or a U for midterm reports, right? So generally, for those midterm reports, I try to be more aggressive about giving students warnings if I feel like they're falling behind, right? So typically, it's like either you're missing it, and typically what that is for sending out an unsatisfactory is that if your exam score is below a certain threshold, that depends. I have to take a look at the exam scores now that they're graded. And the second is if you haven't submitted a certain, some arbitrary cutoff for assignments, probably assignment 4 by the end of next week or by the end of this week. So at that point, then I'll probably send out an unsatisfactory, which again, doesn't matter for it does not matter. Like you can get an unsatisfactory and still get an A in the course. It's just a matter of sending out early warnings. And that's part of why we do it, because it forces you to take notice of it and acknowledge that exists in order in order to move forward. So that's all. Now, I talked about the recursion puzzles yesterday. I'm going to have to put in the due dates for that, but I wanted to talk about Sudoku today and talk about how to do that. A couple of things before that. So just the recursion homework in general. So whiteboard. So first, I'm going to talk about the 8 queens puzzle in a bit more detail. You can hear me talk about this on the video I have at the end of recursion on the 8 queens puzzle. It's a pretty good thing, but again, if you don't play chess, queens are the most powerful piece in chess. Not the kings, the queens are the most powerful piece in chess. Chess, you lose if your king dies, but your queen is vitally important. Your queen is worth 9 points compared to 1 for a pawn, 3 for a bishop or knight, 5 for a rook. So queen is worth more than the two. One queen is worth more than the 2 pieces it is representing combined, just because in terms of power. Now, this is because it can move any number of squares until it collides with another piece in any of the 8 cardinal directions. And I don't know why that suddenly. There we go. Okay, there we go. So now the idea with the chessboard, okay, is with our algorithm is that basically I give you your solve method takes in 2 things. It takes in a board, which is obviously going to be an integer array. It's going to be 2D array of integers. It can't be any, it's just not going to be anything else. I mean, you could do true false for this one, but why? And then you're going to be given a position. What position is depends on the problem. In this one, I highly recommend that your position be column. Because basically what you want to ask yourself is, given this column, what row should I put the queen on? And then if I can put the queen down on this row, on this column, move to the next column. If I can't put a queen down on any space on this column, I need to backtrack. So that is what the return trues and return falses mean in the context of this algorithm. Return true means we finished, we hit an ending point. The return false in the context of this algorithm means the person who the method that recursively called me, which was myself, but like the previous, I'm working on the previous row, that needs to find a new column. The previous queen needs to find a new row to work on. So false means backtrack, true means I finished the problem. And so what we do here is that now the recursion, once you get it working, isn't too bad. In fact, I highly recommend for the is valid statement, right? There's basically, we have this for loop, and inside the pseudocode is an is valid. When you write is valid at the first, I highly recommend you just simply make is valid return true. And every space is a valid place to put a queen. On Sudoku, every place is a valid place to put a 1. Why? Because this will let you know that the recursion works if you're able to put down all 8 queens or fill up all the squares of Sudoku. That's the point. Once you get in, and that part's actually fairly easy if you follow the pseudocode. Once you get to once we solve the is valid, that's the more tricky part. And that's why I love this problem. So the is valid basically means that since we're placing a queen and we don't want to collide with any other queens, that means I have to check all 8 directions, right? I have 8 directions to check for collision. And the answer is that would be cruel. But no, you don't actually have to. First off, we are placing queens in only one direction, this direction, left to right. That means that, and if we can't find a place to put a queen down, we backtrack to the previous column. That means there will never be any queens to the right of us, ever, because we're moving from left to right. Make sense? So that means we don't have to check this, this, or this. Furthermore, our logic is saying, given this column, figure out where to put the queen, what row to put the queen on. That means there's never going to be a queen above or below us because we're trying to figure out what space to put that queen in. And once we put the queen down, we'll move on to the next column. There's never going to be a queen sharing our column. We're trying to figure out where to go in our column. Make sense? And it's our column. There's no way we're going to ever put a queen down the same column. So we don't have to check these. So that leaves us 3 checks. This one is fairly easy. We just simply check if something's in the same row to the left of you. Oh, sorry, yeah, same row as to the left of you. These two are harder, and I highly recommend going with this one since you're checking negative directions. Now, because you're figuring, okay, I'm going now this is the most common mistake I see for students. They figure, okay, I have to check this direction over here, okay? That means I'm going up one direction and to the left in the other direction. So because I've got two directions, that means I need two for loops. The answer is no. You only need one for loop. And I love this problem because it allows you to understand something about for loops. First off, how should we check these directions? I say start at the space your queen is on. So start at this space and radiate outwards. So in other words, start it at my position and then check my position -1. My row -1, my column -1. Then check my row -2, my column -2. Which brings me to my next point. Your for loop, and I'm not going to give it all away, but I'm going to give you the biggest hint I possibly can. Okay? This is an initialization statement over here, right? And this is the post statement over here, right? So we do an assignment statement over here. We declare some variable. You can actually declare multiple variables there if you want to. That's not relevant for this problem. You could, though. Similarly, over here for this statement, you could declare multiple things going on. But this ending condition is a Boolean expression, which means you can have any Boolean expression in there, including one that is compound. So you can have condition 1 and condition 2. And check if they're both true. That will help you out here once you figure that out. Again, I highly recommend for this problem, focus on your isValid function basically starts out saying, okay, everything is true. Every space is good. Then work on just figuring this rook, this out. Turn it into an 8 rooks problem. No queens share the same row with each other, and nor do they share the same column. Diagonals are okay then. Then once you're there, you transform into making sure that they don't collide in any dimension there. Now, with regards to the Sudoku problem, that one, okay, that one when we do solve board is going to be this, it's going to be a interarray again. But position here, in this case, you have two positions, your row and your column. So you should give it, so Sudoku should take a row and a column in because its position is described by two dimensions. You can technically do it with just one, but then you have to do some fancy math to figure out what row and column you're on using some division and some modular arithmetic. And some people prefer to do it that way. So how in the world does Sudoku work? So Sudoku is a Japanese word, although it probably didn't, just like a lot of other games and puzzles and theorems and stuff, it's probably been incarnated in other places throughout history. But Sudoku, the Japanese version of it, is what's become popular. It is literally, the literal translation of Sudoku is a digit single. A lot of languages are very fond of creating abbreviations. We do that in English. Television becomes TV. So Sudoku is short for Suji wa dokushin ni kagiru, which means the digits must be single. Okay, and the rules is that we are given an empty puzzle. So we're given a puzzle with a few places put in, and there's one unique solution for filling it in, and we fill it in according to the rules. The numbers 1 through 9 must occur in each row, each column, and in each 3x3 square. And each number can only occur once in each of those conditions. So in other words, this row, sorry, give me a second to annotate. So this over here can contain only it already has a 3 in it, so it can't contain another 3. In fact, let's go ahead and move over to the New York Times now that we know about it to show how that works. So over here, we've got this puzzle, and I'm going to try to put in a 3 here, and it tells me I got it wrong 3 ways, actually, because I've got it in the same row, same column, same 3 by 3. But let's just start out with the same, doing it in the same row. Actually, it's really hard to do it in the same row over here. Let's see. Yeah, let me put a 1 over here. It says I can't have a 1 because I have a 1 already in this column. I can't have now what about a 7? I have a 7 in this 3 by 3 square already. Can't have a 7 there. Similarly, over here, I've got, I can't put a 4 here because there's a 4 in this 3 by 3 already. So you typically solve this using a bit of logic. Okay, we go, okay, so we've got a 3 here, a 3 here, a 3 here. Where are we missing? We've got a lot of 3s. So we've got a 3 over here. There needs to be a 3 in this row and a 3 in this row. Okay, so we know that 3 can't be in this column, can't be in this column. So it's got to be in one of these positions over here. That's a potential place to put 1. So is that, well, except we can't put it, and we can't put it there. This is the only place a 3 can go. So it has to go here because it can't go here, and 3s can't go here because there's already 3 here. So this is the only logically place that we can do this. So we use a lot of logical kind of induction to figure out where we can put things. Harder puzzles require you typically to say, oh, there's 1 of 2 possibilities. I need to make a guess and try to go off the branch and see if that works. Our computer code is not going to be elegant at all. It's going to basically, I don't want to use the term brute force because that implies that we'd be looking at basically every possible combination, but it's just going to basically go through it basically with no subtlety whatsoever. So we start over here in the top left. Can I put in a 1? No. Can I put in a 2? Okay, move on. 1, no. 2, no. 3, no. 4. Okay, move on. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't put that in, so backtrack. 5, 6. 1, 2, 3, 4. Oh, 1, 2, 3, 4. We found a 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there was nothing there to put in, so backtrack. This is the first easy where I've ever had to backtrack. 7, 8, 9. Okay, now can't put 3 here, 4 here, 5, 6, 7, 8, 7. 1, 2, 3, 4, 4. 1, 2, and 6. Move on to the next row. That space is empty. Move on. Sorry, that space is taken. Move on. 1, 2, 3, 4, 5, 6, 5. Move on. 1, 2, 3, 4, 5, 6. Move on. 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are all taken. So backtrack, move on to the next one. Backtrack, 6, move forward now. So basically you keep backtracking. Now, one of the things that happens a lot during this assignment is that students, they see this and they just, and I tell you, you want your solve to take board, row, column. The point of recursion is that you are solving a local problem. You don't have to look for the next location. You know where the next location you want to solve is. You're on it. You want to check this particular square. So if I don't want to see, I do not want to see any of this. I will make you rewrite it if I do. I don't want to see here. Mouse now. I do not want to see just basically a Sudoku that simply says solve and then takes in a board and then does a for loop on the rows and then a for loop on the columns looking for the next available square. That's really just not what we're trying to do with recursion, and it nests your for loop 3 deep, which makes it really hard to read and more complicated than you need to be. You should know where you are, pass in your row and your column, because then otherwise you don't really know where you were if you have to backtrack. Okay, so pass in a row and a column, please. All right, so I've prattled on long enough about this problem. I will put on a due date for it. Typically I allow a week and a half to 2 weeks on this one, so I'm going to make sure but I'm gonna try to allocate it based on the amount of time that we have left for the all the other assignments. This is the second of the longer length assignments we have. The third long length assignment will be the Cheater's Hangman. So yeah. And now I will go ahead and I'll make my way around the room and listen to your complaints about your exams. Not really, not complaints. They're all valid, I'm sure. Okay.